Oh, hi there. Today we're going to look at something special. Because I know a lot of people working with sound don't like drawing volumes or specifying areas for many reasons. First off, it's not the most creative work you can imagine, and also sometimes the game changes underneath us and we'll need to redraw these volumes that we had placed perfectly on the pixel. So sometimes you make some clever system to identify which area you're in automatically. And that's what we're going to have a look at one of these approaches today. So all of these ambiences are implemented using another component that we're supplying with SweejTech Ambience called the tracer component. And if I just enable the debug here for a second, you can see that it's using line traces to scan the world around the listener. And this is a component that we've placed on the player character. And if I open this blueprint, then you can see that this one inherits from SweejTech Amp tracer component. And that means that I have some data to pull from there, that I have all of the results from the line traces that have been ran asynchronously. And based on this, I can create an indoorness value. And I also calculate some reflections that we'll look at in the future for a tap delay. This indoorness value is used on our indoor global ambience. So as you can see now, this one has a weight of 0. And that's because it's being controlled by another blueprint component that I've created called ambience parameter. And this one is looking at the global parameter indoorness that I set in the audio tracer component. If I edit this one just to see what this one is doing, this one is a completely vanilla actor component. On begin play, I try to get the SweejTech Ambience component from the owner. And then every tick I get the global parameter that we're setting in a variable, in this case indoorness, and I set that as the weight on the ambience component. So this one is set to priority 4. The indoor is the highest priority at priority 4. You can see that in the ambience inspector here as well. We also have rain, which is using the same component, ambience parameter. And this one is looking at the global parameter called rain. If I select the rain actor here and look at the weight, when I enable the rain, you can see that the weight is increasing in time with the rain amount being increased by the gamer. And that's where the rain actor takes precedence over the global default because it has a higher priority. So we're just increasing the weight of the rain, which makes the default global disappear essentially. And we still have this indoor area. And since the line traces aren't all hitting something, some of them go out in each end of the tunnel, we get an indoorness value of somewhere close to 0.9, which means that you still hear some of the rain. Now, if we go to this forest and disable the rain, since the rain has higher priority than the forest, then you can hear this start sounding like a forest. And this one is a different blueprint. So in this one, I get the tracer component, and then I get the trace results, and then I count the number of trees, rocks, boulders, and stuff like that around the listener. And in this example, I'm counting to 10, and that gives us 0.66667. So we use that for the forest's weight. So another very simple implementation that gives me an automagical behavior for this forest. as I walk away from it, I have 0 weight, and as I approach it, you can see that I can find something that has full weight. And for anyone who has dabbled with a system like this, you will know that there are edge cases that can be very difficult to fix. And that's why it's very nice that this is implemented in the same system as the volumes. So you could just create a volume with a higher priority and override that edge case. And all of this is done using 4 actors. Now, of course, these are just 4 locations, but theoretically it would work for no matter how many of these kinds of locations on this level. So this could be the full setup. So yeah, that's 3 ways that you can extend this ambient system that we built. And you can go anywhere you want with this, more or less. You can go way too crazy. But the nice thing is that it's built with performance in mind. So at least the data that you're working with is very optimized, and then you can definitely make too much with it. But at least you have that option. All right, thanks for watching.